Welcome to another teardown video. This time another great Philips product. A PM5126 Sine square oscillator. Look at this. It is just in amazing state. It's looking like it's brand new. Somebody took care of this one like it was their own little baby. Look at this. This one is designed in 1972. If you know when they stopped making and selling those, it could be really cool to know. So please add this in the comments so we can figure out what is the minimum age, because the maximum age is from 72. It looks really nice, and again, just great feeling. Yeah, everything just feels fantastic. There's one little tiny little scratch right there. Oh no! See, the transformator here is a lot smaller compared to the other unit I just looked at. Let's look a little bit at the back. Again, mains in and out, so that's all great. Power out. I would expect this fuse to be the power in fuse, not the power out fuse. So it's located a little bit. What do you think about this? I guess this will read power in. So that means the guys who wanted those to be those isolation things, yeah, well, and again, mains, voltage selection and fuse. This will be the transformator, so it's mounted, so half of it is out here. Right, so maybe we should test it first, as always. I'm gonna plug this thing in. And we're gonna turn on mains so nothing bad happens. And then what we're gonna do is we're going to do this together, okay? Ooh, we got light. 21 watts, are you kidding me? What is this? Unstable. Is it reacting to? Yes, it is. This is a little bit odd. Okay. And of course this meter is not responding to the attenuator, but it's responding to the pot. So far so good. Aha. This one seems to be a little bit. What if we go really low? Then there's no output. Look at that. So this, I have an idea. Let's go super slow and then we crank it up slowly and see. Nope. That means there is a bug in this one. It is dead. In the slowest frequency range, it would be dead. So it should go all the way from 10 Hertz to 1 megahertz. So that is 1 megahertz. I think it's time to connect the scope. Alright, we got output. And of course it's me who's stupid. It helps to read. Ooh. We got some... Of course this pot meter wasn't really in use for a million years. So it's already getting better. But if this is at 10 and this one is in the fastest, then you'll have 1 megahertz, right? I think this is about 1 megahertz. I am a little bit impressed about this. 2 zeros? Are you kidding me? How is that possible? And I put it exactly at 10. Wow. They really knew what they were doing. This is analog, remember? So, let's go 10 down. And then again. Look at that. 2 zeros. Let's go down one more. 10 kilohertz. 1 kilohertz. And this is the slow mode. Yeah, okay. Exactly. Aha! See what I'm doing? I'm working a little bit on this switch. Ooh, I am able to. Yes! Ooh, ooh, ooh. I was able to get it working. So this is 100 hertz. But of course, I can go even lower, right? 10 hertz. Let's see if that is right. I think it is about right. I think we need a little bit more for this to be able to read it accurately. But I think this is very, very close to 10 hertz. Oh my God. Yeah, so. And this is the amplitude. Yeah, so what I'm saying is this thing works. Just this knob needs a little bit of exercise. This is how it's looking when you're changing. Boing. Yeah, it's just fantastic to see what happens when it goes into regulation. So there's some stuff going on in here that needs a little bit of working. Let's see if this is... Oh dear. Where's half of the... That's a little bit funny, isn't it? Let's go a little bit faster and see if this is really like that, right? So look, this is 2.6 volts RMS, and all I do is flip the... Ooh, it's a little bit... So that means... And then, okay. Of course, you got the meter where you can adjust again how much you want. And the meter here is, let's see, is this reading out correctly? So I guess this value would be like peak or something, because I got 5.4 peak and I am in the low output, so that I guess this would be the 50 ohm range, because this is the 600 ohm. So yeah. Aha! And in that mode, the alternator is of no use. Nope, it is not. Only the pot is working. So that is how it works. And the bulb is looking beautiful. I am super happy about this, especially the frequency accuracy is just amazing. Wow. I think you gotta see this as well. I was playing around with the frequency knob again, and then I went back to testing how accurate can I set this, and again I get the 100 Hertz. Fantastic. But see this? Is this good enough? Whoa. How was it possible to make this back in 72? How can you make a potmeter that is this accurate? It's just going on and on in all the ranges, and it doesn't matter what else I do. The range switches here is just super spot on as well. Oops, that was just a tiny too low. Or is it just me? Nope. Let's try and see if this is, am I too low? And then we're back again. Maybe it was just me. But this is just really accurate. Because if you're using an instrument like this for audio testing or for something, it's probably all you got. And it's just absolutely spot on. Alright, we need to open this thing and have a look. This is just so lovely. All you have to do is just turn this, and then it goes flippity flop. Open, open. It is so it is so easy. And look at that. All the PCBs are in sockets. So this is a very different design. Ooh, look at that potmeter. You got somebody has been writing on it. 16083. And look at that meter as well. 74. A74 7491. I was hoping for some date markings. Look at that. It says, oh, let's get some light in here. So it says 2% on that one. So to get, look again. I bet this is the same fantastic. Dude. I love it already. How easy is this? And then flippity floppity out. Oh, this is just so easy to make service on this. You don't even need to take off the side panels. Of course, the side panels is just one screw, and then you flip this open and then pull it out, and then you got the side panels off. Down here. I think we should have a look. Can you do this with one hand? Oh, what is that? This is the bulb. This is the... Oh, they put the wires here, those jerks. So I can't just pull this board out. Hey, but this board, this is the light bulb for the... I think this is the amplitude or something. For the oscillator. This is just... fantastic. Maybe we should try and power it up again and see if there's light in this thing. If it's visible light. But this has something to do with oscillation, amplitude, compensation, something. Absolutely fantastic. And this is just made with a bulb because the parameters of the bulb changes with heat and voltage, and it's just super fantastic for regulation. And of course, could maybe put those boards in wrong. No, you cannot, because they're coated. See, there's this line here, so you can't screw this up, even if you really wanted to. Oops, what is that? A little adjustment. Ooh. Some little tiny picofarads of adjustment, and then we have pure magic somehow. Oops, sorry about that. Let's wait with that a little bit and see if this is really the case. Yep. Look at the coating. It's completely different. See what I'm talking about? This little thingy is not in the same position. So that means you can just pull them out and throw them all over the table, and you can't put it back together. Wrong. But who would be so stupid, I guess? Nobody would. This one looks like a little bit of hand soldering. A little bit of sloppy soldering here in the middle. Maybe somebody tried to change this part at some point. Oh, yeah, there was some Sharpie. Oh, don't touch that. Look at this. Tiny little... this is a dual balanced transistor, and there's another one. Look what this is. Can you see what it is? Two absolutely identical clones of the same circuit. This is, of course, the power supply. Plus and minus 20 volts. And they just copy everything 100% identical. This way you have a positive and a negative 20 volts. And all you do is just connect them in series on the output. And Barbara's your uncle. So, yes, that was the last one. Ooh, there's one thing here I don't really like. Again, look at the mains wires. But here they made them a little bit thicker. The wires that goes out to the other external. But look at the power supply wires in and out. They go directly together with your linear regulation transistors. This will be the power transistors for the power supply. I would never put those in parallel with mains and with AC. You know, you want to have super nice and clean DC. But back then, the last few microvolts or millivolts, maybe it didn't matter that much. Maybe this is not specified to be insanely clean in the sub micro millivolts range. But today, this is a thing. We are crazy about the last digits, and we want super silent, and we want everything to be so clean. Doing. I unscrewed the wire holder here just so we can have a better view of the oscillator bulb. Now we're inside from the back. Look at this. Yes, it was more or less loose. So we got some loose solder here. Yes, it has been lying here for 50 years. When somebody soldered this, it's difficult to get in here. So they were sloppy and touched this with the soldering. So this is the attenuator. And this is all the timing components for all the timing. And again, all you need to do is clean those switches a little bit, and we're good to go. Another 50 years. I'll just use a little bit more. As you see, they move really well. So there is pressure to the contact. It's just a matter of using this a little bit. I really like the way that this mega sized switch is also mounted at the back, just like the other one. This gives you a really good and stable feeling. When you're dialing in, it's just click, clack, and it just works. You have seen a lot of other instruments with really long switches, and when they're not connected in the back, they just go like this, and it looks like really bad, and there's also an odd feeling. About the mechanics, what I found is, look at this. This little screw here actually assembles the two halves of the side aluminium. See? This is how it's assembled. This is really funny way to do it. So it's not soldered or glued or welded or anything. No, just bent, pressed into one of the feet and done. Of course, this is not a problem here because this one is mounted in another way, so it's a different one. Look at that. Really funny. And of course the other one is here. So this is a great way to hide it, or just to do it. Yeah. All right. I think that is all I wanted to show from this magnificent Philips unit. I hope you had fun. Now I will put it together again.